Hey YouTube family, Namaste. I hope that all of you are very fine. This is Shubhro Devnath and I welcome all of you to my channel Bengal Bro Tutorial. Welcome to the fourth lecture of the chapter Electric Charges and Fields. In this video lecture, we are going to discuss all about Coulomb's law. But before we start the session, just a bit of information for those who are new to this channel. Students, you all can easily avail the lecture notes from the link given in the description box. Also, if you have any doubt regarding today's class, you can ask me in the comment section. So without any further delay, let's get started. It was in the year 1785, a French physicist named Charles Augustin Coulomb, who began performing experiments to measure the force between charged bodies. He used small metallic charged spheres and a torsion balance to perform his experiments. A torsion balance is a sensitive device that is used to measure force. Now when he sat down and began to perform his experiment, he realized that the exact magnitude of charge in the metallic spheres were unknown to him. So he thought of a simple idea to solve the problem by assuming that the total charge in one of the metallic charged sphere to be equal to Q, and brought it in contact with another sphere of identical size but uncharged. Now can you guess exactly what happened after that? Well, in the method of charging called conduction, we learned that when two conducting bodies are brought in contact with each other, then their total charge gets equally distributed in the two bodies. Similarly, in this case also, when the two metallic spheres were brought in contact with each other, then the charge on one metallic sphere equal to Q and the charge on the other metallic sphere is equal to 0, being uncharged. So the total charge in the two sphere is equal to Q, and upon coming in contact with each other, this total charge will get equally distributed in the two spheres, and now each sphere will have a charge equal to Q by 2. He kept repeating this process to get charges equal to Q by 4, Q by 8 and so on. Now, after that, he took different pairs of charges and measured the force between them for different distances of separation, which means that he took pair of charges somewhat like this. He took two spheres that may have same charge, or he took two spheres that may have different charge, and then measured the force between them for different distances of separation for each pair of charge and noted them down. Finally, formulating all his observation in the form of a law which we now know as the Coulomb's law of electrostatic force. According to this law, the force of attraction or repulsion between two stationary point charges is directly proportional to the product of the magnitudes of the two charges and inversely proportional to the square of the distance between them. This force acts along the line joining the two charges. Here you have to note one very small term: stationary point charges. Stationary means something that is at rest. Now what do we mean by point charges? When the linear size of the charged bodies are much smaller than the distance separating them, the charged bodies are treated as point charges. Means, assume that we have a charged sphere having radius equal to 1 meter. Here in West Bengal, and another identical sphere means having a radius equal to 1 meter in Maharashtra. Now obviously the distance between West Bengal and Maharashtra is very large compared to their radius. So in this case we can treat the charged bodies as point charges and can simply represent them using a point. Understood the meaning of point charge? So you have to note one thing, that Coulomb's law is applicable only for stationary point charges. This is one of the limitation of Coulomb's law. Limitation of Coulomb's law. Holds only for stationary point charges. Which means that the charged bodies have to be at rest, as well as the distance of separation between the charged bodies have to be very large compared to their linear sizes. Now the force is directly proportional to the product of the magnitudes of the two charges. Let us assume 2-point charge Q1 and Q2 separated by a distance equal to r. Now according to Coulomb's law, the force of attraction or repulsion between these point charges will be directly proportional to the product of the magnitudes of the two charges. Means as this value of product will increase, the force between them will also increase, and the force is inversely proportional to the square of the distance between them, which means that as the distance between the two charged bodies will keep increasing, the force between the two charged bodies will keep decreasing, because square of distance and force is inversely proportional. Now if we combine these two expressions, we get F proportional to Q1 Q2 by r square. If we replace this proportionality sign with an equal sign, then we have to multiply this side with a constant, say small k. So the expression becomes F is equal to k Q1 Q2 by r square. Here k is the proportionality constant. Which is also known as electrostatic force constant. Now this value of k depends on two factors. First factor, nature of medium between the 2-point charges. And the second factor is system of units chosen. System of units chosen to measure F, Q1, Q2 and R. So understood, this value of k will change when we change the medium between the two charged particles and If we change the system of units that is used to measure these values, then the value of K will change. Now, when there is no medium between the charged particles, that means the charged particles are placed in vacuum. For particles or for charged particles placed in vacuum or in air and in SI unit, means we are measuring the values of F, Q1, Q2 and R in SI unit. The value of K will become equal to 1 by 4 pi epsilon naught, which is equal to 9 into 10 to the power 9 Newton meter square per Coulomb square. Here epsilon naught means it is another constant which is called as the permittivity of free space. Okay, so when the two particles, charged particles, are placed at some distance apart in vacuum and we measure the different values of force, the magnitude of charge of the two particles and the distance of separation between them in SI unit, the value of K becomes equal to 1 by 4 pi epsilon naught, which is equal to 9 into 10 to the power 9 Newton meter square per Coulomb square. Now, here epsilon naught means permittivity of free space. The unit of epsilon naught will be just the inverse of this unit because K is inversely proportional to epsilon naught. 4 and pi, they are constants and they don't have any units. So, obviously, the unit of epsilon naught will just be opposite to that of K because they are inversely proportional. So, unit of permittivity will be equal to Coulomb square meter square inverse and Newton inverse. This is the unit of permittivity of free space. Now, in electrostatic CGS unit, okay, before that another thing, this is the maximum value of K that is possible. So, this is the maximum value of K. Alright. Now, for the two charged particles placed in vacuum or air and in electrostatic CGS unit, the value of K is equal to 1. Okay. Now, if the particles are placed in medium, in any medium, and in SI units, value of K is equal to 1 by 4 pi epsilon m. Here epsilon m is the permittivity of that medium in which the two charged particles are placed. Understood? So, we can write the Coulomb's law for two charged particles placed in vacuum and in SI unit as is equal to 1 by 4 pi epsilon naught Q1 Q2 by R square, and for two charged particles placed in any medium and in SI unit as F medium is equal to 1 by 4 pi epsilon m q1 q2 by r square. These two expressions are known as the scalar forms of Coulomb's law, because from this expression you cannot get any idea regarding the direction of the force. But force being a vector quantity, it will be very better if we actually express this expression in the vector form. So now let's see the vector form of Coulomb's law. In order to derive the expression for the vector form of Coulomb's law, let us consider 2 point charges q1 and q2 placed at points A and B having position vectors r1 and r2, which means that the position of charge q1 with respect to origin is r1 and the position of charge q2 with respect to origin is r2. Now students, please pay attention or you will get confused. Vector leading from charge q1 to q2 can be represented by r21. I am repeating once again, r21 represents the vector which is starting from charge q1 and ending in charge q2. And if you look at the diagram, means we are talking about AB vector. See, AB vector is starting from charge q1 and ending in charge q2. Here the first digit is representing the end point of the vector and the second digit is representing the starting point of the vector. Similarly, BA vector can be represented as r12. Means BA vector is the vector which is starting from charge q2 and ending in charge q1. First digit is representing the end point of the vector A, q1 charge, and second digit is representing the starting point of the vector which is B, q2. Alright. Now if we use triangle law of vector addition in triangle OAB using triangle law of vector addition, in triangle OAB, then we can either write OA plus AB is equal to OB. If we go in the clockwise direction, see, OA plus AB equals to AB. Or if we go in the anti-clockwise direction, then we can write OB plus BA is equal to OA. Okay. Now OA vector is equal to R1 vector. AB vector means R21. And OB vector means R2 vector. Similarly here also R2 vector plus R12 vector is equal to R1 vector. It implies R21 is equal to R2 minus R1 and R12 vector is equal to R1 minus R2. Up to this much you all have understood? Well, now unit vector in the direction of R21 can be written as R21 cap is equal to R21 vector by mod of R21 vector, and unit vector in the direction of R12 can be written as R12 cap is equal to R12 vector by mod of R12. Did not understand? See, any vector, say p vector, can be represented as mod p into p cap. Here mod p represents the magnitude of vector p and p cap is the unit vector in the direction of vector p. So basically p cap is representing the direction of this vector. So from here we can write that p cap is equal to p vector by mod p. We are doing the same thing only here. Okay. Now note another important thing. Force on Q2 due to Q1. How we can represent? We can represent it in this way. F21, force on 2 due to 1, means we are talking about the force that will be experienced by charge Q2 due to the presence of the charge Q1, and the direction of this force is going to be along R21 vector, because these two are like charges, so they will repel each other and the charge Q2 will move away from charge Q1 because of the repulsive force. So here F21 will be in this direction and this is the vector representing F21. Similarly, force on Q1 due to Q2 will be represented as F12. Here we are talking about the force which Q1 charge will experience due to the presence of charge Q2, and the two charge being like, they will repel each other and Q1 will move away due to the repulsive force. So this is the vector which is representing F12, and F12 is in the direction of R12. See, R12 and F12 are in the same direction. Okay. Now if we use Coulomb's law, then we can write that F21 is equal to 1 by 4 pi epsilon naught, considering that the two charges are in vacuum, Q1 Q2 by mod of R12 square into R12 cap. This part of the expression is giving us the magnitude of force and this part is giving us the direction. Sorry, actually it is going to be R21. And if you match it with the diagram, you will see F21 is in the direction of R21. And F12 can be written as 1 by 4 pi epsilon naught Q1 Q2 by mod of R12 square into R12 cap. Just check the diagram. F12 is in the direction of R12. So this part is giving us the magnitude of force 12 and this part is giving us the direction. Now in the next step, we are going to just substitute R12 cap with this value, and then we will get 1 by 4 pi epsilon naught Q1 Q2 by mod of R21 square into R21 cap can be written as R21 vector by mod of R21. Okay, so if we simplify it, then we can write 1 by 4 pi epsilon naught Q1 Q2 into R21 vector by mod of R21 cube. R21 square into mod of R21 is equal to R21 cube. And here also we can write that 1 by 4 pi epsilon naught q1 q2 into r12 vector by mod of r12 cube, like this only. So these two expressions this and this expression represents the vector form of Coulomb's law. And in exam, if you are asked to derive the vector form of Coulomb's law, then you can either approach in this way or in this way. Both these expressions represent the vector form of Coulomb's law. Also, if you want to express them in terms of position vector r1 and r2, that also you can do. Let me express F12 in terms of r1 and r2 only. Now, F12 vector is equal to q1 q2 by 4 pi epsilon naught r12 vector by mod of r12 cube. Just replace r12 with r1 minus r2. r12 equals to r1 minus r2. Then what you will get? q1 q2 by 4 pi epsilon naught r1 vector minus r2 vector by mod of r1 minus r2 whole cube. So this is the expression for the vector form of Coulomb's law in terms of position vectors. Similarly, this will be F21. F21 can be written as F21 is equal to q1 q2 by 4 pi epsilon naught mod of r2 minus r1 vector by mod of r2 minus r1 whole cube. This is the expression for F21 in terms of position vector. Okay. Now we are going to look at some very important points regarding the vector form of Coulomb's law. Although while deriving the expression for the vector form of Coulomb's law, we had taken two charges of same sign, which means that they were like charges. But the expression is valid for charges of any sign, whether positive or negative. See, if q1 and q2 are either both positive or both negative, which means that the product q1 q2 will always be greater than 0. Then in such a case, the direction of F21 will be along R21 and direction of F12 will be along R12. Now, if Q1 and Q2 are unlike, which means that if one is positive and the other is negative, and the product Q1 Q2 will always be less than 0. Now see here that if Q1 is positive and Q2 is negative, then we will have a minus sign here, which means that the direction of F21 is opposite to the direction of R21. Minus sign is indicating that the direction of F21 is opposite to the direction of R21, which means that F21 is along R12. F21 will be along R12 and F12, okay, when they are positive, one is positive and the other is negative, then there will be a minus sign here which will indicate that F12 will be opposite to the direction of R12. Now this is the direction of F12. If this is the direction of R12, then F12 will be opposite to the direction of R12. So you can easily see that the expression for the vector form of Coulomb's law is applicable for any kind of charges, whether positive or negative. Although Coulomb discovered his law without knowing the exact magnitude of charge in the metallic spheres, but his law can be used to easily define the SI unit of charge. According to Coulomb's law, we have a vacuum is equal to 1 by 4 pi epsilon naught Q1 Q2 by R square. If Q1 is equal to Q2 is equal to 1 Coulomb and R is equal to 1 meter, which means that the magnitude of charge in Q1 and Q2 is equal to 1 Coulomb and they are separated by a distance of 1 meter, then a vacuum is equal to 1 by 4 pi epsilon naught, which is equal to 9 into 10 to the power 9 Newton. So we can define the SI unit of charge as 1 Coulomb is that amount of charge which repels a similar charge with a force of 9 into 10 to the power 9 Newton when placed in vacuum at a distance of 1 meter apart. See, suppose I have given you two charges Q1 and Q2 whose magnitudes you don't know, but the two charges are identical, which means that they have same magnitude and same sign. Now you have found out that the force exerted by one charge on the other is equal to 9 into 10 to the power 9 Newton. Now this is only possible when the magnitude of charge in both the charges will be equal to 1 Coulomb and if they are separated by a distance of 1 meter. So we can say that 1 Coulomb is that amount of charge which will repel a similar charge with a force of 9 into 10 to the power 9 Newton when they are placed in vacuum at a distance of 1 meter apart. This is the definition of 1 Coulomb or SI unit of charge. So that's all for today. Hoping to see you very soon in another video. Till then, take care of yourself, keep studying for your exam and have a wonderful day ahead. Bye.